Let's start lecture 10, and the course series name is Corrosion Protection Methods. And today's topic will be some of the design aspects, pictorial representation of those design aspects. We have already discussed guidelines, the problems that can happen due to poor design, as well as we talked about the factors which can affect the design. Now, we will be giving some specific, the more number of examples. We have given already some examples, we will just add some more examples. So, it is basically examples of better design, the topic. The course is Corrosion Protection Methods. Lecture 10. Topic: more examples, better design, and mostly it will be based on geometry. Now, let us say we talk about some examples to avoid local attack, mainly crevice. Let us say we have used a gasket. So, let us say this is my gasket, this is my gasket, and this is the other matching surface. So, this is my gasket. So, let me put it in green color. This is my gasket and this is the other surface. Now, if we have a gasket, so if you press it hard, the end point of the gasket, if it is protruded, that would have a bend towards this, the top part, and that time there could be a possibility of crevice. So, the best way to avoid such kind of stuff, instead of having this protruded part, you just chop it off. So, you can chop it off from here. The design could be like this. So, this is my gasket, this is my gasket, and the rest of the part is okay. We are having load like this. So, what we are doing? We are cut off the protruded part. Okay. So, this is one such example. Now, let us say we have a tank or vessel. Let us say this is my vessel. Right. So, one can keep it on top of a flat platform. So, this is my platform. And this is the vessel. Again, we are creating crevice. Now, This will again lead to a corrosion damage around this part, either this particular surface as well as this particular surface. There will be corrosion related due to crevice corrosion. So, this is the crevice part. In fact, the crevice in the previous example, it would have been here. Those are the crevice attack point. In fact, so this can go downwards, and if it is under load, there could be, if this is under load, let us say bending load, then there could be possibility of failure from that point. So, this was better design in the previous case. So, this is bad, this is better. This is also bad because two crevices you have generated. The design modification, you have a tank, and instead of having a flat platform and then creating crevice, we can make it like this. This is the platform on top of which the vessel is kept. Okay. Now, here you see, so that means this particular crevice points are out here, as well as there could be crevice, a local crevice around this portion. One way to handle it, if you have cement, you just put cement and make a curvature over there, and then you have tackled the crevice related issues. So, this is a better design. Now, again, let us say you have a cement pillar, on top of it you have put a thick rod or large diameter rod, and here also we have crevice. Now, in order to avoid this, this is bad, and if this is cement, this concrete, the major problem would happen around this zone, okay. And in fact, there could be possibility of crack in the concrete also, because the corrosion would happen just below this. Just below this, severe corrosion can happen. Outside would have corrosion, but it will be less corrosion. And this is interesting because again it is a question of, it is a matter of concentration cell. Because the outside part we have a lot of oxygen, the inner part we have less oxygen. So, it can actually lead to a local concentration cell, and the inside part can have higher degree of corrosion, that means that part is anode. So, that can be possible, that can be stopped if we have cement which has very high degree of water imperviousness. Okay. So, that means water cannot ingress through that particular concrete mixture, but still the crevice point can lead to attack in the steel component of the particular rod. The possible way to resolve this, if you have, again this is my design, better design, you have that particular rod going through this, you can put a cement mixture like this. Okay. So, what happens? You have actually blocked the crevice. Okay. So, you can avoid this. So, this is a better design. Fine. Now, again let us say we are doing a spot welding. So, if we have square section, let us say, let us say this is the square section. So, this one section is connected to other section. Okay. Now, if we do spot welding here, these are the spot welding points. Whatever matching surface you create, there will be crevice segments here. So, this particular segment, there will be small gap and that gap can lead to crevice. So, whenever we have such kind of situation, it is better to do continuous welding. So, if we do continuous welding like this over the entire segment, continuously we weld, so that all those crevice gaps, all the small gaps can be closed down. So, the green part, which is, that means bad design, is spot welding, better continuous welding. Continuous welding. So, these are couple of examples related to design or aspect related to geometry. So, you are actually avoiding crevice. Let us have some examples related to water retention. So, let us say we have a design like this kind of design, let us say. Let us say roof. So, that roof design, so water can accumulate here and create corrosion problem. This is bad. The better design would be make it reverse, so water cannot accumulate. And in fact, this sharp corner should be avoided. So, it is better to have a design like this, okay, a rounded portion. So, this is a better design, water accumulation can be stopped. Then there could be possibility of this. This. So, again water can accumulate here. So, those portion, water accumulation, water retention. So, this is bad, better design. So the retention points are out, and you can make it little rounded. So rounded portion. So then this is, you can also avoid crevice. So this is avoidance of crevice. As well as water retention point. So this is better. Then, so there could be possibility of water retention in pipeline system. So if let us say the pipeline system is bent like this, there is a downward slope, but there could be a bend like this. So let us say water is coming. So during a maintenance, there could be possibility of water retention around this part. Pipeline will be emptied out, but this portion, some water will be left out. So this will also lead to corrosion. So if we have a slope in a pipeline, that slope should be continuous, and there should not be bent like this, which is bad. This is a bad situation. So the better situation would be you have a straight and continuous bend. So this is better. So the water retention problem can be avoided to a great extent. Now there could be issues related to erosion corrosion. Erosion corrosion we have already talked, using of rounded corners or bends in a pipeline flowing water system, as well as there could be smooth pipe inner surface. So if there are humps or a kind of dent, so those dent as well as hump portions can lead to turbulence and can have extra bit of erosion corrosion. And then also we talked about using deflector or buffle plate. So let us have little more examples. So this is examples related to water impingement. Or splash. So now one possible is, for example, you have a tank which stores dilute solution, and if you are mixing concentrated fluid from outside, so there could be issues like this. For example, if you have a tank like this, so you have a entry pipe, this is my tank, and let us say water line is here, this is dilute, and let us say concentrated solution is coming from through this pipeline. And this is dilute solution. So this is coming, and so there could be impingement on top of it, and that could lead to splash. So this is splash zone, around this zone is a splash zone, fine. So this wall, this particular wall can have corrosion. So we can say there could be possibility of severe wet and dry kind of corrosion, as well as concentrated solution is actually sticking to the surface. It can lead to higher degree of corrosion there. So in fact, we have to avoid this splash. So one way to avoid this splash is reduce the gap between the exit point in the pipeline system through which the concentrated solution is coming out, and the dilute solution, the top layer of the dilute solution. So that gap should be reduced. So this gap we have to reduce. Gap should be reduced to avoid splash. Now, this is poor, and the better design could be, so this is my tank where I am holding dilute solution. So, we can have a pipeline, and that pipeline would be sitting very close to the dilute solution layer, the top layer, so that the splash is minimum. At the same time, this particular pipe system should be at the center part of it. This is close to the center of that particular tank. It is not on the side. So, this is on the side. So, this particular pipe is on the side. So, the particular side pipeline fitted to the tank could create splash, as well as that splash concentrated solution can stick to the wall of the tank. But here, even if little splash happens, that particular splash cannot go and hit the wall of the tank. Okay. So, that way we can avoid. So, you see we can avoid splash related corrosion problem. So, this gap is less. So, little splash, and that splash, even if that splash is happening, because it is positioned in the center. So, we have minimum concentrated solution sticking to the surface. Or the wall. Okay. So, we can avoid the problem related to this splash. So, this is better design. Now, in this case, another problem would be noticed. So, here we have a crevice. So, that can have crevice related issue. But here, since there is no bend in the inlet pipe, we can avoid crevice. But one can have this design instead of the center position. Let us say this is my design, thinking that I am avoiding that crevice part, there is no bend in the pipe which is entering into the tank. But if the dilute solution layer is here and the gap between the exit point of that pipe, inlet pipe, and the water layer, dilute solution layer is high, again splash can happen, and that splash will be closer to the wall of the tank. So, that can lead to another another problem, severe problem, because it can, lot of solution can stick to the surface of the this particular wall, and corrosion can happen. So, you are avoiding crevice, but you are actually bringing in another problem of splash, more splash. So, this is also poor. Okay. So, that way one can actually avoid impingement as well as splash in case of situation like this. There could be issues of splash. For example, if there is overflow, there is a tank and fluid or water, let us say, is stored, and if the water goes on top of it, the tank, and that can overflow, and if that overflown water falls on underlying structures, let us say this is my underlying structures. So, this water can impinge over this particular structure, and if it is a metallic structure, that can lead to erosion corrosion again. So, even if we experience overflow, that particular overflown water should not fall on some underlying structure. The best way would be, we should have a proper boundary so that overflow can be avoided. So, avoid overflow. it actually avoid waste of water, as well as this impingement corrosion related problem can be avoided. So, the better design would be, this is poor. So, the better design could be, we have a tank and we make sure that the water line should not go beyond the edge of that particular tank. So, overflow is stopped. So, it stops wastage of water, as well as even if that underlying structure is there, there is no question of having impingement. So, this is a better design. Fine. So, this is related to impingement or splash related problems. So, we will discuss more such problems, as well as what could be the way out to avoid those problems and related to design aspects. So, till we will talk about those problems in subsequent lectures. Most likely in the next lecture we will finish it off, we will finish this design related aspects, and then we will catch up with some aspects related to materials and operating conditions for devising or designing corrosion protection methods. So, the kind of examples what you have seen, you can follow one reference book. So, there also you will find these examples. So, it is basically, I would say, resource. So, this book you can also follow. So, let us stop here. We will continue our discussion on examples of better design in our next lecture. Thank you.